The calculators allow one to eliminate quantized values unless because of program design or measure type that is necessary, of course. But then the important thing is, as Joe's referenced, they're shared by everybody in the domain. They are actually the embodiment of the standard, of the specification, and they carry their own supporting documentation around to provide a significant audit trail. And then because they're centrally versioned, everyone is current always. So sort of graphically, what smart measures are, is I've kind of referenced this, and this is, I will show you this in the software momentarily, but briefly then there is the measure application data. That's the additional inputs that are used that will feed the calculations. This is information decided or determined by the measure designer or the consultants. And then the smart measure itself actually then houses the algorithms as structured data and any assumed values that are necessary for the calculations. And then of course this is just a live calculator that's capable of producing its results. Those calculations can be from rebate to savings, KW, carbon emissions, water, etc. The spectrum of measures that we find across the country, we find many jurisdictions really using unitary measures, deemed savings, and custom. The area where we think the smart measures are really going to have that ability is to actually be implemented in both unitary and deemed algorithms to put that into a structured format and help us move to more sophisticated calculators that are more accurate and automate the data capture for EM&V purposes. The demo today, I'm going to actually demonstrate the measure design tool. I will actually select one of the Minnesota deemed calculators. But of course, the Smart Measure Design tool can be used to build non-deemed calculators. I will show you how you can collect both MAD data, the measure application data, but if you want to, you can collect some additional data that may not feed the calculations, but for example, could be important for EM&V purposes. I'll show you the version management, how we formalized this into a structured format to handle the versioning problems for measures in our domain. And I'll talk a little bit about library management and then documentation. So with that, now I've already logged in. I'd like to just make sure, can everybody see this screen? Can anybody get back to me and confirm that they can still see this screen?
Yep, I can see it.
Perfect. Thanks, Mike. So the first thing I'd like to do is just give you a little sense. This is our navigation bar. And in here, I'm really just going to, as I mentioned, I'm just going to show you sort of three attributes of the functionality on ESP. I'm really going to be digging into the area that we call smart measures. I'm going to get into the lab. And a smart measure lab is where the measure calculators get created. They're formally versioned. They carry around their specification. It's the area for the specification that typically goes in a TRM. And then finally, it's also that repository for any of the supporting documentation for those measures. That's what the lab is. The library is a collection of measures, and I will just show you what that's like. And then the final thing, I do want to show you the shares. And shares are how people who own resources on ESP, the state of Minnesota, for example, can share its library with all of the utilities in Minnesota. So in the lab, as I've selected this, I have all of the calculators, the smart measures that Minnesota has built in ESP. And the one that I'm going to select, I've got a C&I lighting metal halide retrofit. And the first thing is this measure has been selected. You'll note over here in the right-hand side, we give people the ability to view every previous version of this measure that was in use. In this Gantt chart-like view with the blue line will show you which version of the measure was live when. The red line is today. And here I've got my list of previous versions of the measure. So on ESP, you always get the ability to go back in to view the previous versions of the measure that were in use. But then I've got a future version. And so you can't edit previous versions of the measure because, of course, those are being used by portfolios in the state. And so you don't want to go modify a calculator that's already being used across the state. But I do have a future version, and you can create future versions. And so this is the one that I want to show you very briefly what the Smart Measure Design tool looks like. And what we do as a software developer is we build the building blocks in software to allow engineers or consultants to build whatever kind of calculators they need to run their programs. And so as this measure is getting called up here, and it looks like I've got a little lag time, and I do apologize for that. There we are. So this is a schematic design tool, and I'm going to shrink the work surface a little bit. But I know this will be hard to read, but this is actually a calculator then that's been built by the state of Minnesota, so it's a deemed calculator. And you'll see each one of these rectangles. And here we have the standard outputs for every measure, typical things that you would expect to see. And then each one of these rectangles, and just to show you this is a live work surface, this measure that's been built, each one of these rectangles is a certain type of calculator. They come from the building blocks that we as software builders build these different building blocks that the measure designers need to build their calculators. And so if this was actually a brand new work surface and somebody was wanting to drag one of the building blocks over, so for example, I'm dragging an expression calculator over into the work surface, and then that represents itself, and then I could actually go and build an expression calculator. But I'm going to open one up. Here I have, looks like Joe and the consultants in Minnesota built a KW factor override. I'm going to click on the pencil, which would allow me to come in here and edit and or view this expression calculator. Here you can see I've got two inputs. I could have as many inputs as I want. And then I've got my expression. So here's the expression, and if I needed to modify this in any way, the consultants or those who have the privileges to edit these can come in and modify those formulas. So I'm going to hit the cancel button because I don't want to make those changes to this. Another one of the building blocks is what we call it a multi-dimensional selector. Basically, this is literally an n-dimensional lookup table. And the one I'm going to pick is building type. Building type is, you might know from typical deemed kind of calculators, building types can drive the output values for coincident demand factor and annual operating hours. And so this is where the consultant can come in and build their drop-down list or a menu and then have the different output values for each one of those different building types. And if there was a study where this was getting tuned up, and let's say the coincident demand factor went to 0.72, my annual operating hours went to 2425, I could update the different input or output values for each one of the different building types. And this literally is an n-dimensional matrix. I can add some additional dimensions. I can also delete the course items in the list if I wanted to eliminate a building type, for example. And I can have as many outputs for each one of these selection matrices as you so desire. So the measure designer then, as they're building up their calculators, the way for them without having to call IT or call us to say I would like the output values from a particular calculator to get fed into another calculator, it's what all of the wiring is. The wiring is where it's for the measure designer can say I would like these output values to go be fed into this particular calculator. And so as I select this, if I wanted to change the output and have this go to someplace else inside my calculator, I can go make those kinds of adjustments. So this is a deemed calculator that's already built. The Smart Measure Designer, I told you, has the ability to decide what measure application data do we need to collect to inform the calculations. And so just to show you that this is a live calculator, I'm going to select a couple of the values. And you can see then as I come over here to the smart measure as it's laid out on, in essence, kind of the operating table, you can see the different values that are going through the calculator as I hover over each of the different variables. And so this is the data that's required for the savings calculations. But if I also had a desire to collect additional data, maybe input data that might feed my EM&V effort, I could drag, for example, a numeric variable over into the work surface. I click the Edit button, and let's just say we wanted to collect building square footage for this type of calculator. And I'm going to select a couple of things without a lot of description because we don't have time, but we'll make it an integer. I would like this to be data that is required to be collected out as these measures are used. And I'll put that up near the top on the display. So here I've now got building square footage. It'll now show up under quantity. And so what we're allowing folks the ability to do is decide what measure application data they need to collect and what other additional data maybe they need to collect inside this tool that might speed or reduce that time or allow the evaluators to come in and as they're seeing results coming in real time. Maybe this is an input data that they want to to capture up front. So that's a very quick intro to the measure design tool. The next thing on the version management that I'd like to show you, so if we pretend that I actually modified that calculator and I now wanted that calculator to go live at a specific time in the future, I can click Edit Smart Measure Version Timing, and up pops an editor that allows me to control when that smart measure goes live. So again, I can see the previous versions of the smart measure. I can see the one that's currently in flight. And then the final version here, well, that's all the way out to infinity, so it's a long time from now. But if I wanted that to go live, let's say I've got a building code change coming on July 1st, I can drag my start date back to July 1st. And on July 1st, as time just rolls forward, this version of this smart measure will go live in the portfolio. I could also drag it back today if I wanted that to go live today, and I could hit the Save button and then that would go live today, but we'll leave it here in April. I'll hit the Save button, and this is how folks manage what version is live when across this. As this is a Minnesota measure across the state of Minnesota, and you'll see that this will modify or change to April in 2015. So smart measures also carry around actually their own specifications. So they're live calculators, but they carry around their own specification. I won't dig into that because we really just don't have time for that. But here in the Edit Smart Measure, this is where the actual specification or measure characterization documentation is. And then this is that opportunity to upload whatever supporting EM&V studies might be to support the development of this smart measure. So that's a brief look at the Smart Measure Lab. Libraries, as I mentioned, libraries are collections of measures from the lab. And so the state of Minnesota, I'm selecting their set of libraries. Organizations on ESP can have as many libraries as they want. And again, libraries are just different collections of smart measures. Minnesota, you can see, has 5, in essence, different libraries, but the current one is the Minnesota TRM. And so as I select the Minnesota TRM, the view, I'm given the ability to see which smart measures are live across the state of Minnesota in this smart measure right now, or sorry, this TRM right now. If I wanted to modify what smart measures were in the library, I can click the Edit button. And with, we call it time-based architecture, simple ability to turn measures on and off formally. This functionality gives the state the ability to decide what measures are in the TRM. And so we could go in here, and if one of these measures was no longer going to be suitable at some time, I could come in and drop that measure off today. I could actually drop a couple of them off or drop them off at different times through the year. I could also, if I built some additional measures in my lab and I wanted to see what other measures were in the lab, or I wanted to add measures from the lab, I could come in, and the ones that are currently sort of grayed out are currently in the lab and available to be put into the TRM. And if I drag, I call it a slice of time over here on this CNI fridge freezer retrofit, I could drag and add that measure into the library. Now I'm not operating on the real Minnesota TRM, so I can go ahead and save this. And then you can see those changes would get made to the Minnesota TRM, and it's a very simple way to update that TRM and make it available to, or update it for all the utilities across the jurisdiction. So that's libraries. And then the final piece of functionality I want to show is what we call shares. These are pretty powerful, I guess, one of our first two collaboration tools, and the one that I want to speak a little bit about today. Shares is pretty powerful, and shares gives the organization that owns the resource the ability to share those resources with anybody else on ESP. So this is where Minnesota controls who has access to what smart measures. Let me find, there's the current Minnesota TRM. And here, as I select the current TRM, you can see which utilities in Minnesota this TRM is shared with. Actually, it's, of course, all of the utilities in Minnesota. But the time-based architecture would give an organization the ability to turn the sharing functionality off if they want, or to control when somebody has access to that resource. So that's a very brief introduction into the Smart Measure tool. Let me come back into the presentation. I had just a couple more slides. Joe kind of hinted that this current iteration of the TRM, they've invited their consulting organizations to come in as helper organizations to come in and modify and create new smart measures on behalf of the state, and we call those helper organizations. So here we just depict where a helper organization might come in and modify some smart measures on behalf of, well, a state or a utility. The concept of helper organizations can also, though, be used on ESP. They can be consultants who are doing program design, implementers who are creating or running programs on behalf of a utility. They can be, helpers can be contractors creating projects, and helpers can also be evaluators that are analyzing this rich measure application data. So those are helpers. These smart measures, of course, what's really happening conceptually, but it's hard to show in the software, is that by putting actual live calculators that are versioned and managed in the cloud, the utilities with their own tracking systems can actually then integrate and consume the smart measures. And so the two different utilities with their own different tracking systems can consume the same smart measure to ensure that they're using the correct version and always producing the correct claims in real time. So that's what sharing of smart measures is. For us, on the power of the collaboration of shares on ESP, so really I just want to highlight the share aspect is that any organization may have one or more libraries and share them with any number of organizations. So what that could mean, as we've talked in Minnesota, Minnesota then builds a library, shares it with 184 utilities, as well as their implementers. And Minnesota has also offered to share its TRM with its smart measures with other states. And then, of course, the utilities, though, in Minnesota can also build their own smart measure libraries. And in fact, we have utilities in Minnesota who are building program designs using smart measures from the Minnesota TRM library and some of their own smart measures. And they, of course, could share those with other organizations outside of Minnesota in their own right. Regions could use this type of functionality where you might have a regional library. Let's say it's MIA, for example, and MIA builds a set of standard smart measures for everybody to use in the Midwest. Each state could then have their own repository of measures to maybe supplement some of the ones that were being used in the region. And then utilities operating in the region might be able to access measures out of the regional library, the state library, their own library, and any other shared library. And this kind of flexibility was really built, and it will allow utilities operating across multiple jurisdictions to build multiple libraries for their and manage those centrally, where they could have a core library to share common measures across the utility, and then have each of the jurisdictions maybe have supplemental measures that they use in their own programs in their own state. And of course, this would allow functionality at a national level as well. So finally, to wrap this up, what Joe and I believe sort of the value of the digital TRM is to lower the implementation and maintenance costs for everybody in the domain, that we achieve standards actually trying to make it easy to use and access, provide greater access to the functionality that's already been built. And this will really lead to more credible data, which we think is really essential in our domain, with tight version control, reducing the reliance on simple deemed averages where it's not necessary. Again, clearly there's, if you're selling retail, light bulbs across a retail chain, you must use a deemed value because there's no way to collect some of that measure application data. But it can allow us to have more sophisticated calculators. It's a tighter feedback loop because the evaluation folks can be brought in real time and be seeing the data coming in as projects are being created. So we think it can tighten that feedback loop. Richer data, we will capture a lot of rich measure application data that can provide some deeper analysis and understanding about what's happening. And of course, this kind of functionality can increase the transparency of how savings are calculated, what assumed values or real values are being used to calculate the savings, and inevitably leading into some better program and policy development. With that stated, I thank you for your time, and we would be happy to open this up for questions.